Welcome to the Deep Dive, the show where we take a stack of sources and pull out the knowledge nuggets you need to get informed fast. Today we're diving deep into a topic that's, well, suddenly everywhere. Prompt engineering. We've got a white paper here that really digs into it, what it is, why it matters, and how to actually get good at it.
That's right. Yeah, whether you're prepping for a meeting, trying to get up to speed in a field that's just moving incredibly fast, or maybe you're just really curious, this deep dive is all about understanding how to, talk effectively to these large language models. We're going to unpack the core ideas, look at a bunch of different techniques, and share some key best practices, all straight from this document.
So the mission for today, pretty simple, really. Pull out the most important stuff from this paper so you can start crafting better prompts and getting, well, more useful results from AI. Okay, let's get into it.
All right, so before we even think about writing the prompt itself, the source highlights something really crucial. It's how the model is configured. That's fundamental. It's not just the words you type you see, but also the knobs and dials you tune behind the scenes.
Knobs and dial, you mean like controlling how long the answer is?
Exactly. Output length, usually measured in tokens. And, more tokens generally means more computation, maybe slower responses, definitely higher costs sometimes. The paper points out, though, that just setting a limit doesn't automatically make the output shorter or better. It might just chop it off mid-thought.
Right.
So if you need a concise answer, your prompt has to ask for that too. This is apparently pretty important for some specific techniques later, like React, where the model might generate extra stuff you don't need after the actual answer.
Got it. So output length is key for efficiency, cost, makes sense. What about creativity or randomness? I've heard these models can sometimes, go a bit off the rails.
Yeah, they can. That's where the sampling controls come in. See, LLMs basically predict probabilities for what the next word or token should be. Temperature, top K, and top P are the main settings that kind of nudge how the model picks a single token from all those probabilities.
Temperature, I've heard that one. Like making it hotter or colder affects creativity. Is that the idea?
That's a pretty good analogy, actually. Lower temperatures, so closer to zero, they lead to more deterministic output. The model almost always picks the single most likely next token. A temperature of exactly zero is called greedy decoding.
Greedy, okay.
Right. And higher temperatures. They introduce more randomness, more diversity. It's more likely to pick less common words. But really high temperatures can make the other settings like top K and top P almost irrelevant. The source mentioned Gemini's temperature setting is kind of like a softmax function, emphasizing one choice at low temps, spreading it out more at higher ones.
Okay, interesting. And top K and top P, are they similar? Do they do the same thing?
Yes, they also manage randomness, but they do it by restricting the pool of possible tokens before the selection happens. Top K just says, only consider the K most likely tokens.
Right.
So a lower K means fewer choices, maybe more factual output. Higher K means more room for creativity. And a top K of 1 is also greedy decoding, just like temperature 0. Top P, which is sometimes called nucleus sampling, selects tokens whose probabilities add up cumulatively to a certain value P. So P can range from 0, which is greedy again, up to 1, which considers basically all possible tokens.
So how do you decide which one to use? Or do you use them together? It sounds kind of complicated.
Well, the document basically says you need to experiment. If you have all three settings available, the tokens usually have to pass both the top K and top P filters first. Then temperature gets applied to whatever's left. If temperature isn't an option, it just picks randomly from the tokens that made it through K and P. But it does warn that, extreme settings on one can cancel out the others, like temp 0 or top K1 makes the others pointless.
Right, because it's already picked the single best one.
Exactly.
Yeah.
But the source does give some helpful starting points, like for results that are reasonably coherent but still creative, maybe try temp.2, top P.95, top K30.
Okay.
For really creative stuff, maybe push temp way up to 0.9, top P 0.999, top K40. Less creative, maybe temp.1, top P 0.9, top K20. And for tasks where there's really only one right answer, start with temp Terra.
That's super helpful, practical starting points. Any warnings or pitfalls with these?
Yeah, one thing they mention is the repetition loop bug, where the model just gets stuck saying the same word or phrase over and over.
Oh, I've seen that happen.
Yeah, apparently it can happen at both low and high temperatures, just for different reasons. And fixing it often means carefully tweaking these sampling settings. It really underlines how important getting the configuration right is.
Okay, so we've configured the model, set the stage. Now let's get to the main act. Actually writing the prompt. The document dives into a whole range of techniques. Where do we start?
We start with the simplest one, general prompting, or as it's often called, Zero shot.
Zero shot.
Yeah. This is just giving the model a task description and maybe some text to work with, like asking a question or giving it the start of a story. The zero-shot name just means you're not giving it any examples of how to answer. The source uses that example of classifying movie reviews, positive, neutral, or negative. Table 1 shows the prompt. Classify movie reviews. Review. Her is a disturbing study. Masterpiece. Sentiment. And the model outputs positive. It notes, though, that words like disturbing and masterpiece make it kind of complex, right? It also stresses how important it is to document your prompts, maybe using a table format like they show later.
Okay, so zero shot is just asking directly. What happens if that doesn't quite cut it? If the model gets confused?
Then you bring in the examples. That takes us to one-shot and few-shot prompting. Examples are super powerful for helping the model understand exactly what you want, especially the output structure or specific patterns.
One shot is one example, few shot is a few.
Exactly. One shot gives a single input-output pair. Few shot gives multiple.
How many is few? Is there a magic number?
The document suggests maybe 3 to 5 as a good rule of thumb to start. But it really depends on, how tricky the task is, how good your examples are, and model limits like how much text you can even feed it. The main idea is to show a clear pattern. Table 2 has this great few-shot example for parsing pizza orders into JSON. It shows how providing examples, like one with a half-half order, teaches the model how to handle that complexity and structure the output correctly. The source really emphasizes using relevant, diverse, high-quality examples, maybe even include some edge cases to make it robust.
So examples teach the specific pattern. What about setting the overall context or maybe the tone, like be helpful or talk like a pirate?
Right. That's where system, contextual, and role prompting come into play. The source breaks these down, although it notes there can definitely be some overlap between them. System prompting sets the overall context or purpose for the interaction, like translate the following text or classify these items. It can also specify how to return the output. Table 3 shows a system prompt for classifying reviews, but it adds a specific instruction. Only return the label in uppercase. Table 4 shows specifying a JSON output format with a schema. The source really highlights the benefits of JSON output for data extraction. It's structured, can be sorted, might reduce hallucinations, handles data types, all that good stuff. System prompts can also be used for safety, like adding, "You should be respectful in your answer."
Makes sense. What about role prompting?
Role prompting is about giving the model a specific character or identity to adopt, like act as a book editor, or a fifth-grade teacher, or a seasoned travel guide. This really shapes the response's style, voice, and even the kind of knowledge it draws on.
Ah, like method acting for AI.
Kind of.
Yeah.
Table 5 shows the travel guide role suggesting places in Amsterdam. Table 6 takes it further, adding a humorous style to the travel guide role for suggestions in Manhattan. The source lists a bunch of possible styles: confrontational, humorous, persuasive, etc. Defining a role basically gives the AI a blueprint for its tone and expertise.
And contextual prompting, how's that different?
Contextual prompting provides specific, immediate details relevant to the current task or turn in the conversation. Think of it as the here and now information. Table 7 shows providing context like, you are writing for a blog about retro 80s arcade video games before asking for article topics. The source says this helps the model grasp nuances and tailor its response much better, leading to more accurate and relevant output.
I see. So system is the overall job, role is the personality, and contextual is the specific briefing for this task. You could layer them, right?
Absolutely. You could have a system prompt setting the task, a role prompt defining the voice, and contextual prompts feeding in specifics as the conversation goes on.
Those are really useful ways to guide the model. Now, what about techniques for more complex reasoning, getting it to actually think through problems?
Yeah, the source gets into some more advanced stuff here. One interesting one is step-back prompting. Yeah, the idea is before you ask your very specific question, you first ask the LLM a related but more general or high-level question. Then you take the answer to that general question and include it in the prompt for your specific task.
Huh. Why do that? Seems like extra work.
It is an extra step, but the source argues it helps the model sort of activate the right background knowledge and reasoning principles before it dives into the specifics. It allows the LLM to think more critically, maybe pull in relevant concepts, and potentially even mitigate some biases by considering the bigger picture first. Tables 8, 9, and 10 have this neat example about creating an FPS game storyline. Asking a general question first about engaging themes for FPS games actually resulted in a better, more structured, specific storyline compared to just asking for the storyline directly.
Interesting. Like warming up its reasoning engine first. What about chain of thought? difficulty. That one seems fundamental.
Oh, absolutely. Chain of thought prompt is huge. It's basically getting the model to generate intermediate reasoning steps before it gives the final answer. You're essentially asking it to show its work.
Right, like in math class.
Exactly. The source says this significantly boosts reasoning capabilities, especially for complex tasks that really need steps before you get to the answer. And it often works really well combined with few-shot prompting, showing it an example of step-by-step thinking. The advantages listed are pretty compelling. It's low effort to implement, often works well right out of the box, and it makes the model's reasoning more interpretable because you can actually see the steps it took. It also seems to make prompts more robust across different model versions.
Any downsides?
The main one is just that generating all those extra steps uses more tokens, which means potentially higher costs and slower response times.
The document gives that classic math problem example, right, where zero-shot just fails.
Yes, it's a perfect illustration. Table 11 shows asking, when I was 3, my partner was 3 times my age. Now I'm 20. How old is my partner? The zero-shot prompt gets it wrong, gives 63.
Yeah, that's way off.
But then, Table 12 shows just adding, let's think step by step, and bam, the model outputs the correct reasoning and gets the right answer, 26. Table 13 then shows how providing a single-shot coup example can refine that process even further. The source notes QT is great for tasks you can solve by sort of talking through the steps, like generating code or even creating synthetic data.
Okay, so breaking down the problem helps the model follow along. What's self-consistency then? How does that build on QT?
Right. Self-consistency takes chain of thought and adds sampling and voting. Instead of just generating one chain of thought, which might still be flawed.
Like the first attempt in QT?
Exactly. Instead, you prompt the model multiple times for the same problem, but you use a high temperature setting to encourage diverse reasoning paths. You get several different step-by-step answers.
Okay.
Then you extract the final answer from each of those different paths, and you choose the answer that appears most often, basically, a majority vote.
Like crowdsourcing the answer from the AI itself? Trying different ways to think about it and picking the most popular conclusion?
That's a great way to put it. The source says it improves accuracy and coherence, especially on tricky problems, by considering multiple perspectives or lines of reasoning. The email classification example in Table 14 hints at this. Maybe one pass focuses on friendly tone, another on sarcasm, leading to different classifications. Self-consistency aims for the most robust answer across these attempts.
The downside must be cost, right? Running it multiple times.
Yeah, that's the big trade-off. It can be significantly more expensive due to generating many responses for a single query.
And tree of thoughts, TOTI, how does that fit in?
Tree of thoughts, or TOTI, kind of generalizes chain of thought even further. Instead of just one linear chain of steps or even multiple separate chains like in self-consistency, TOTI explores multiple reasoning paths simultaneously. It builds out a tree structure of thoughts.
Oh.
Yeah, the source says this is really well suited for complex tasks that require actual exploration or looking ahead down different paths. Figure 1 in the source visualizes this branching idea. It's moving from a line of thought to a whole network.
From a chain to a whole tree, that's a big leap. Okay, finally, react. Reason and act. What's that about?
React is a really interesting paradigm. It combines the model's internal natural language reasoning, like chain of thought, with the ability for the LLM to use external tools.
Goals? Like what?
Like searching the web, running a piece of code, accessing a database, things like that. It tries to mimic how humans often reason and then take action to find information we don't have. The source calls it a step towards agent modeling that works in this loop: thought, action, observation. The LLM thinks about the problem, figures out it needs external info, thought, it plans an action like formulating a search query, action. It performs the action using the tool, it gets the result back, observation, and then it uses that observation to update its internal reasoning, thought, and plan the next step, if needed.
Okay, so it can actually do things to get information.
Exactly. Snippets 1 and 2 show a Python example using a framework called LangChain. The task is to find out how many children Metallica band members have. You see the LLM outputting its thought, then an action, a specific search query, then getting back the observation, the search result snippet, and it loops like this until it synthesizes the final answer. The source does note that using React effectively often involves managing the history of prompts and responses, maybe trimming things to stay within context limits.
That's incredibly powerful, letting the model interact with the outside world. Okay, that's a lot of techniques. It sounds like prompt engineering itself can get pretty complex. Is there any way to automate it?
Well, yes. The source actually introduces something called automatic prompt engineering, or APE. And it's kind of meta. It's basically using a model to help generate more prompts.
Wait, you prompt an AI to write prompts for an AI?
Pretty much. You give a model a task and ask it to generate variations on how you might prompt another model for that task, or variations of few-shot examples.
Hmm.
Then you'd evaluate those generated prompts, maybe using automated metrics or human review, and select or refine the best ones.
The example was generating different ways to phrase a t-shirt order, wasn't it?
Correct. Table 15 shows asking Gemini Pro to generate 10 different ways to say one Metallica t-shirt size S. The source suggests APE can boost performance and, importantly, reduce the amount of human effort needed just to come up with lots of prompt variations for testing.
Very interesting. Okay, beyond just conversation or problem solving, the source also dedicates a good chunk of space to using LLMs for coding tasks.
It does, yeah. Models like Gemini can be really helpful for writing code, explaining code, translating between programming languages, and even debugging. The source makes the point that this can significantly speed up the development process for programmers. Table 16 shows an example prompting Gemini to write a bash script to rename files in a folder. And it's pretty good. It even includes comments explaining the code. But, and this is a really important point, the source hammers home. Because LLMs don't truly reason or understand code deeply, and they might just repeat errors present in their training data, you absolutely must carefully read and test any code they generate.
Trust but verify, always.
Always. The source actually walks through testing that generated bash script to confirm it works correctly. Then, Table 17 shows using the model to explain bash code. Super useful if you inherit some complex script or you're learning a new language.
Yeah, I could see using that.
Table 18 demonstrates translating code, taking that bash script and turning it into a Python snippet. This is great for moving logic between systems or maybe building a graphical interface for a command line tool. It does note a small detail about needing specific formatting for Python code in Vertex AI Studio, and maybe the most useful part. Table 19 covers debugging and code review. The source intentionally introduces a bug into the Python code using two uppercase instead of Python's uppers. They feed the broken code and the resulting error message back to the model. And the model not only finds and fixes that specific typo, but also suggests several other improvements, like handling file extensions better, dealing with spaces in file names, using more modern Python features like f-strings, and adding error handling.
Wow, so it goes beyond just fixing the immediate bug.
Yeah, it acts like a helpful code reviewer, suggesting ways to make the code more robust and maintainable in general. It's really quite practical for developers.
Incredibly practical. The source also briefly mentioned multimodal prompting somewhere. Just quickly, what was that?
Oh, right. Yeah, it just notes that multimodal prompting is kind of a separate concept where you guide the LLM using multiple types of input, not just text, but maybe images, audio, code, depending on what the model supports. Asking questions about an image would be an example. It's distinct from the text-based techniques we've been focusing on.
Got it. Okay, this feels like a perfect point to shift into the best practices section. The source wraps up with a lot of tips for becoming a, quote, prompting expert. What are the really big takeaways here?
Well, the number one takeaway, echoing through the whole document really, is that prompt engineering is an iterative process. It requires tinkering, experimenting. You try something, see what happens, adjust, try again. Using tools like Vertex AI Studio can help manage this experimentation. And probably the single most important technique emphasized as a best practice is providing examples using one-shot or few-shot prompting whenever possible. The source calls it a powerful teaching tool. It helps the model learn the output you want, the style, the tone, and really improves accuracy.
Simplicity seems to be another big theme.
Absolutely. Designed with simplicity, prompts should be concise, clear, easy for both you and the model to understand. Avoid overly complex sentences or packing too much into one request. They give that great before example. I'm visiting New York right now. Where should we go during our vacation? I'm with 2-3-year-old kids. It's rambling. The after rewrite is much cleaner. Act as a travel guide for tourists. Describe great places to visit in New York, Manhattan with a 3-year-old. Much clearer. Using strong verbs like act, analyze, classify, generate, summarize also helps focus the prompt.
And the point about using instructions over constraints, that felt a bit counterintuitive to me at first.
Yeah, it can seem that way. But the source argues that focusing on positive instructions, telling the model what to do, is often more effective than telling it what not to do. Instructions directly guide it towards the goal while allowing some flexibility. Constraints can sometimes be too limiting or even clash with each other. So instead of do not list video game names, maybe say only discuss the console, the company who made it, the year, and total sales. You're still constraining it, but by giving a positive instruction about what to include. Constraints definitely still have their place, especially for safety or very strict formats, but the advice is to prioritize clear, positive instructions first.
Okay, that makes more sense. Guide it towards what you want rather than just away from what you don't.
Precisely. Other practices mentioned are controlling that max token length we talked about earlier, either via the configuration or just by phrasing your prompt, summarize in one paragraph. And using variables in prompts, Table 20 shows this, makes them reusable and dynamic, which is super important if you're building prompts into an application.
Experimentation really is the recurring theme, isn't it?
Definitely. Experiment with different ways of phrasing your request as a question, a statement, an instruction. Try different writing styles. Different approaches can yield surprisingly different results. For few-shot classifications specifically, they advise mixing up the order of the classes in your examples. Don't always put positive first, then negative. Mix it up so the model doesn't accidentally learn that order matters. Starting with maybe 6 examples is a good rule of thumb there.
Good tip.
And adapt. When models get updated, test your prompts on the new versions. They might behave differently. Use tools like Vertex AI Studio to track these changes. Also, experiment with structured output formats like JSON or XML, especially for non-creative tasks because of all those benefits we mentioned, structure, fewer hallucinations, etc.
And it even mentioned fixing bad JSON.
Yeah, it acknowledges that sometimes, maybe due to token limits, you might get back invalid JSON. The source points out there are libraries, like JSON Repair, that can actually help fix malformed JSON from LLMs. Pretty practical. Related to that structured output point, the source highlights working with schemas, like JSON schemas, and not just for defining the output format, but potentially providing schemas for your input data too.
Input schemas, how does that help?
Well, if you provide data along with its schema, it gives the LLM a really clear blueprint of the data's structure and the types of information in each field. Snippet 5 shows this. This can help it focus on the relevant parts and understand the data better, reducing misinterpretation. The example, Snippet 6, shows providing product data that conforms to a schema, including a specific release date field. The source suggests this makes the model more time-aware of that data, helping it generate more accurate, contextually relevant descriptions. This seems especially valuable for large or complex data sets and applications.
So structure input and output with schemas when you can. Any final tips on the process itself?
Yeah, a couple more. One is to experiment together with other prompt engineers, if possible. Share what works, what doesn't. Even following best practices, there's variance. And crucially, maybe the most important process tip, document your prompt attempts. Seriously, keep detailed records. This is essential for learning, for revisiting your work, for testing against new model versions, and for debugging when things go wrong.
What should you record?
The source recommends using a template, like the one in Table 21. Track things like a name for the prompt, the goal, the model used, all the configuration settings, temp, top K, etc. The exact prompt text, the output you got, the model version, whether the result was okay or not okay, and any feedback or notes. It also suggests maybe storing prompts in your code base separate from other code, and even using automated tests to evaluate them regularly.
So it's a real engineering discipline.
It really is. The whole process is cyclical. Craft, test, analyze, document, refine, repeat. And be ready to re-experiment whenever the models or configurations change.
Wow, okay. From understanding those core settings like temperature and sampling, to mastering techniques like chain of thought and React, and then layering on all those best practices, simplicity, specificity, examples, documentation, that was genuinely a deep dive into prompt engineering.
It really was. It shows that getting the best out of these incredibly powerful models isn't just about, typing a casual question. It's this blend of understanding how the model thinks, applying proven techniques, and then really refining your approach through careful, iterative experimentation.
It's almost like learning a new language, isn't it? A language to talk to these prediction engines, but one where the grammar and vocabulary seem to be constantly evolving.
That's a great analogy. Yeah. And maybe that leaves you with a question to chew on. In a world where these models are getting more and more capable, and we're even seeing techniques like automatic prompt engineering emerge, what will the role of the human prompt engineer look like down the road?
Something to think about for sure.
Yeah.
That wraps up this deep dive. We hope you feel a little more well-informed, maybe ready to start engineering some great prompts yourself. Join us next time for another deep dive.